Hi everybody! It's time to start talking about resistors and what they do in circuits when there are multiple resistors. Now, last week in lab, I know that you did some work with this. You hopefully experimentally found the relationships that we're going to talk about today. However, I want to go at them from a theoretical perspective and explain why they come about, rather than just throw the equations out. This is something you can actually work out pretty easily for yourself if you're ever trapped on the proverbial desert island and need to make resistors out of coconuts to make a radio to signal for help or whatever you're going to have to do. So let's start with resistors in series. So I got a voltage source, a battery, V. Okay, got resistor R1. I've got a resistor R2. Okay, and it goes back to the battery. So the question is, what is the effective equivalent resistance of both of these resistors combined? Now, from a theoretical perspective, just thinking about it without putting any math behind it, you can actually kind of hopefully see that the total resistance should be the sum of the two resistors. We talked about resistance a week or so ago, and we concluded that the resistance went up linearly proportional to the length of a resistor and went down as 1 over the area. In this case, we're keeping the area of the resistors the same, and we are just basically making a resistor that's twice as long. Now, it's possible the resistors have other different properties to them, but it's going to turn out not to matter. Okay, so that intuition actually is perfectly correct, I'd want to emphasize. However, how do you figure out the total resistances? Well, we need one more thing. We need to talk about the current coming through these, and I hope I can convince you the current going over R1 must be the same as the current going over R2. There's no other place for it to go. There's no place for the charges to leak out, so they have to just keep on trucking. This is basically another continuity equation. Remember that from last semester we did fluids. Continuity equation, but for electricity. Well, that means that if we go all the way around the circuit, we know that we must have a full 1V drop from here all the way around to here, okay? That's what that battery tells us, is that there's got to be a if this is 1 volt, a 1 volt drop, or if V is 10 volts, a 10 volt drop, whatever it is. So we know that V must be equal to the drops over each of the resistors. But what is that? That's just I R1 plus I R2. Well, factoring, that's I R1 plus R2. Well, hey, this looks a lot like Ohm's law. V is equal to IR, but R has just been replaced with the sum of the resistors. That's what we mean by equivalent resistance. It looks like, if I couldn't see these two resistors, that I would just have a resistor in there equal to R1 plus R2. So the conclusion here is R equivalent is just R1 plus R2. Now you might ask yourself, what happens if we have 3 resistors? 4, 5, 10, 50? Pick a number. Well, it turns out that you just keep adding them. One after the other after the other. You can kind of see that just by bootstrapping. These two would be the first equivalent resistor. If we had another one here, could do these two first to make an equivalent, and then that one would be equivalent plus this one. They'd add on. You just keep adding them. So how about an example problem, John? Glad you asked. Let's say I've got a 5 ohm resistor and a 10 ohm resistor, okay, in a circuit. And I've got an, 12 volt battery here. And you want to know the current going through. Well, the equivalent resistance is the sum of those, so it's 15 ohms, 5 ohms plus 10 ohms. And so the current will be V over R, which is 12 volts over 15 ohms, which is equal to, check me, 0.8 amps. Okay? That easy. All right? For anything to do with this circuit, as long as we don't have current branching out anywhere in between them, these two resistors act the same as a 15 ohm resistor. I can work out the power going through this thing the same way. Just treat them collectively like one 15 ohm resistor. All right, that's enough on series. Next up, parallel.